welcome everybody, and welcome to this presentation. I hope everyone can hear me just fine.
Yeah, you're good.
Okay, good. So today I'll present on To Each Its Own, will consumer IoT devices be the last line of defense? So this is more of a discussion or a presentation that should provoke one's thoughts. It's not one where I would present a sort of solution, but it's something more of that would trigger minds for discussion. So in light of that, what I'll be talking about is that I'll give a brief background on Internet of Things. We talk about threats and countermeasures in Internet of Things, also challenges involved in making the countermeasures in Internet of Things. And then look at the possible defense from devices. In this case, we're looking at trust. I would then provide a brief conclusion, and we shall then go on to some Q&A. So let's start. So what is Internet of Things? So I'll start with the devices that are actually used in Internet of Things, the things in actual fact. So these are sensors and actuators. They can actually have some processing and networking capabilities, because without that, they can't connect to the internet. And then they are predominantly featured with embedded technology. So you combine all these, and then they can, and these allow them to communicate with each other and other entities over the internet. So the Internet of Things. So this is where you have devices with sensors, embedded technology, processing and networking capabilities, and they connect with each other. So where do you find them? You can find them in smart homes, buildings, and industries. In the industries, that's where you actually coin the term industrial Internet of Things. And then with consumer Internet of Things would be those that are more or less not found in the industrial settings. So they vary from having your cameras to your smart fridges, smart microwaves, smart sockets, smart watches, and all that. Smart vehicles, you see them all around you. So now this is an actual consumer IoT setup. Now I've actually provided two types here. So one where, for example, you're a human, as a human, you're walking around with your phone and your watch. And then I have actually given the home settings as well. So for the home settings, so for example, you would have your camera, which would more often in most architectures these days, you would have them connected through a hub. That is, if you're using certain protocols like Zigbee or Z-Wave, which cannot reach quite far, you would always have them connected to a hub. And then that hub would then connect to a cloud. So from that cloud, you can actually have access, say through a cell phone or through your computer, and you can actually see the status of your devices from here. So which means you can actually control them, or you can see the status as well on what is going on there. Of course, one of the major enablers with IoT would be IP version 6. So for example, if you have devices that have that capability, it is not uncommon for you to have the devices actually connecting directly to a cloud or to a certain infrastructure, or where you can actually have that sort of communication. We are looking at the network aspect of it. Chances are you would probably have to NAT it at some point. Or if you're using IP version 4, for example, you'd have to NAT at some point. So that's where the cloud seems to be a very important part of it. So what are the threats within IoT? Well, we can start with hardware software injection. I'm pretty sure more presentation after me, and there were some that were before me, would have mentioned the famous Mirai, for which it actually identified devices that used default passwords and then compromised it and then loaded their own firmware for them to become bots to use in a command control setting. So that is one of them. Then you would also have jamming. So in jamming, what happens is that the communication channels are jammed by the attacker to ensure that there is no communication going on. So for example, if you're looking at this setting here, if you were here, one of the jamming would actually be performed in this area. Or if you, for example, we are dealing with a smartwatch, in this case, jam the Bluetooth. So another common one, which you would also see and is also predominant in your normal IT environment, is DDoS attacks, where you bombard a device with a lot of requests. For example, one of them would be that, such that the device is overwhelmed and then shuts down. And then we have eavesdropping in this scenario, where it's more of a passive attack, where you have an attacker that actually listens on the communication channels to see what sort of messages is going on back and forth between the IoT device and the user. We also have side channel attacks. So for side channel attacks, where physical property of the device is actually used to determine what sort of attack or what sort of information to be released. It could even be the temperature of a device at a certain stage, or even what sort of say frequency the radio is actually operating on. And all these would be ways for which information can be released or information can be obtained, and also compromise as well, this side channel attacks. And other ones such as privacy leakages, where you're having sensitive information being released. So for example, you're using a smartwatch which actually takes for example, your pulse, your heart rate and all that, and these information can be retrieved, for example, and especially if you're someone with a medical condition, that can be, anyone can decide to make inferences based on, say, your heartbeats per minute or something of the sort, to say, well, there is something wrong with you, and can be used for malicious intent. So what are the countermeasure challenges within IoT? Even though, yes, there are some countermeasure challenges, there are some countermeasures, there are some challenges. I'll discuss those first before we talk about the challenges involved. So for some of the challenges is that, for example, existing countermeasures for IT do not work with IoT. This is mostly because of, one, the heterogeneity of those devices, because you are dealing with having different devices. You can even pick one device, say for example a camera, and the operating system being used for that camera, the firmware, the hardware would vary. So because of that, implementing there are certain countermeasures that you would implement. Say for example, if you're dealing with IT, you would know that, well, if you're doing a patch for, say, a certain operating system, that would be straight, but for devices, it's actually going to be a challenge. And also the resource constrained nature of the devices is also a challenge as well, because, for example, if you're trying to, say, encrypt, for example, certain encryption protocols are very resource intensive, or requires a lot of computation, and some of them might not be feasible for IoT. So these are the countermeasures. So for example, securing firmware updates is one of them, making sure your firmware updates is secure or done over a secure channel. Authentication, which would be trying to make sure, for the basic one would be ensuring that the basic default credentials are taken out. Others use marks and HMARCs as well for authentication. Encryption of communication channels, that is also one of them. And then identification of compromised devices. So in this situation where there are some researchers that have used machine learning to identify challenges with to identify compromised devices. So now let's look at the IoT attack points. So for example, these are the possible attack points that you have here, for example, in this situation. So as with the case of Mirai, for example, where it identified, or it did a search. So it always has to go through a communication channel, which is that give or take. And based on that, once an agent or once an adversary compromises a channel, then from there would perform many kinds of attacks to probe the device, and then from there would be able to have access to the device. So one of the core things for the attack point for attacking would always be to compromise the channel. So in this situation, for example, one can decide, well, I can perform a security check here or through the hub. But then, for example, for these devices, what if an attacker actually compromises the channel between the devices and say the hub, or the devices and the cloud, or the devices and the phone? In this case, how would the device fend for itself? In this situation, you would realize that the device would then be sitting on its own and at the mercy of the attacker. So one might also add by saying that, well, what if yes, you have all these authentication protocols in place, the credentials in place? Well, that is fine. Let's look at it from a point of view like the movies, for example. You have Mission Impossible, for example, where the protagonist can actually pick up the face of his opponent and then can actually infiltrate the system. So which means has all the credentials in place, manages to walk through into the system and then retrieve whatever he wants. But then the only part where the protagonist is found out by the adversarial team is that they realize, no, this person wouldn't behave this way. And that is how that happens. So the point is, you can have, for example, where social engineering attacks may be employed, where credentials may be obtained, challenge and answer questions may be obtained, but then once used, you can actually have access to the devices. And then in such a situation, what do you do? So in this situation, as I already mentioned, these are the questions. What if the attacker requires all authentication procedures that legitimizes it? So then what happens? How does the user then identify that the user is an attacker? So in this situation, you're having, the attacker has all the information that is required, but then how would you check that? So once a colleague of mine, Dr. Ida Shahan, also mentioned that you'd also have to look at the behavior of whoever actually has that, has these credentials. So in this situation, what if we could make the device cognitive or think on its own? Yes, you're dealing with IoT, so I'm putting the word cognitive in quotes because one might think, well, IoT devices, due to the resource constraints, cannot think for themselves, and trying to implement AI would be challenging, and which is true. So what if we use something sort of like trust? And in this situation, we're not looking at TPMs, we are not looking at trusted platform modules. So we are looking at more of social context. So in this situation where you're looking at trust being the subjective belief about the behavior of a particular entity. So in this situation, you're saying that, well, you perform a certain way, so I can trust you in that because, or for example, looking at the fact that we are dealing with a resource restricted, even though the IoT device will be resource constrained, it means that its functionalities or expected functionalities would also be resource constrained. So what this also means is that then there's a possibility that you can always do trust around those sort of expected functionalities, such that if I'm expecting you to do this and I see a different behavior, then that should mean that, well, whatever activity that you're performing is not trustworthy. So with trust has different criteria. There's been a lot of research around it. People use for example, a certain number of responses or connectivity or tasks performed, for example. And there, of course, there also has been a large focus on trust on routing, for example, in terms of where you're dealing with wireless and SAN networks where they are remotely deployed, and then you're trying to see what sort of device hasn't been compromised. Trust based on routing is also used as well, and then also in commerce as well. So it would be one of the things that we would also need to look at, or the focus would also be on, would be in identifying intrusion. So one such scenario would be that, assuming if trust one device has an attacker has actually compromised the system and logs in, well, as an IoT device, the expectation would be, what would you like to do? Query this, query this, query that. But then if you start trying to say upload a weird firmware, I should probably say no, or based on a certain logic, it should just shut down and prevent you from actually going in, or notify the user before actually shutting down. So in this situation, for example, as I mentioned, there is a possibility that if one is actually implementing trust, can actually implement it in any of these layers. So here I am actually presenting 3 possible layers for the IoT software architecture, for example, where one can actually implement trust based on a certain application, or would actually implement it based on the firmware. So this is one application. So for example, we're looking at certain devices whereby, for example, you can have certain devices where there are RTOS, real-time operating systems, where it's just firmware and then the application, and you also have certain devices like, for example, your Raspberry Pis that actually run on Linux and have their firmware and have the applications. You can also try and have trust implemented there. So in this case, you would need certain trust models to implement in there. And this would be an interesting route to actually go through. As I mentioned, this is more or less like a thought-provoking aspect. So in conclusion, what am I saying? What I'm recapitulating is that a device-centric approach is definitely required to complement IoT defense. And then one of them would be that is trust. And then to, of course, successfully implement trust, the context is always very key, and the trust would always vary from one situation to the other. And of course, which is also one of the challenges when a lot of researchers are actually defining trust, is mainly because the context always varies. So thank you very much. These are my references.